With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is the most common oxidation state exhibited by the D block elements in the 3D series is. So you're given 4 options regarding the concept. Okay. So basically, if we talk about the 3D series, let us just see what elements are present in the 3D series. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are all the elements present in the 3D series of the periodic table, right? So what is the configuration for scandium? We are going to write down the outer configuration, right? The outer configuration is going to be 3D1 4s2, right? I am writing here the outer configuration. The overall configuration will be like argon 3D1 4s2, right? And this is how it is going to be for all the elements as well. So we are just writing the outer configuration. Titanium will be 3D2 4s2. Vanadium will be 3D3 4s2. Chromium will be 3D 5 4s1. Okay. So let's just make some space for others so that we can understand it clearly. So this will be chromium, manganese, iron, cobalt, nickel, copper, zinc, right? So now the configuration for chromium will be 3d5 4s1 because shifting one electron from s to d is going to make it stable and half-filled configuration. That is why the configuration is written as 3d5 4s1. For manganese, this will be 3d5 4s2. For iron, it will be 3d6 4s2. Cobalt 3d7 4s2. Nickel 3d8 4s2. Copper 3d10 4s1 and zinc 3d10 4s2. So this is how one electron has been added in the 3D orbital, and that's how the electronic configuration is written. Now if we talk about the oxidation states exhibited by them, then now scandium can show an oxidation state of either +2 or +3, right? Because it can either lose 2 of its s electrons or it can lose 2 of its s electrons and 1 d electron, right? So it can show +2 and +3 oxidation state. Talking about titanium, it can show +2 oxidation state, it can show +3 oxidation state, it can show +4 oxidation state as well. Because it can either lose the 2 s electrons and along with it, it can also lose 1d or 2d electrons, right? So if we talk about vanadium, similarly it can have +2 oxidation state, it can have a +3 oxidation state, it can have a +4 oxidation state, and it can have a +5 oxidation state. So these are the possible oxidation states for vanadium, because when it loses all of its electrons, it will have +5. If it loses all of its s electrons, it will have +2, and if it loses 1 or 2 d electrons, it will be +3 and +4. Chromium will have plus. Now, what will be the oxidation state of chromium? Now, it can have an oxidation state of +1. It can have an oxidation state of +2. It can have an oxidation state of +3 as well. Then +4, +5, and +6. Talking about manganese, it can have +2 because it can lose the s electrons. Then it can have an electronic configuration of +3, +4, +5, +6, and +7. Right? Talking about iron, iron shows an oxidation state of +2, +3, +4, +5, and +6. Cobalt shows an oxidation +3, +4, +5. Nickel shows +2 or +3. Also, it can sometimes show +4 oxidation state. Talking about copper, copper can show either +1 oxidation state or +2 oxidation state. I'm talking about zinc. Zinc shows a +2 oxidation state because it has a completely filled d orbital and therefore it does not lose electrons from the d orbital. So if now you look at all the elements, you see that the +2 oxidation state is common in each of the elements, right? +2 oxidation state is common in each of the oxidation states, which is shown by all the elements of the D block, right? So if we look at the answer, the option 1 is +3 due to the participation of NS and NP. No, +3 is not the most common oxidation state, right? Because not all the elements are having +3, right? Copper and zinc do not show +3 oxidation state. Talking about option 2, +3 due to the participation of NS and N-1d electrons. Again, not an answer because +3 cannot be shown. Talking about option 3, +2 due to the participation of NS electrons. Now, this is going to be the correct answer for the question because in most of the elements, NS electrons are lost and it shows an oxidation state of +2, right? So, therefore, the correct answer is option 3. Talking about option 4, we have +2 due to the participation of N-1d. No, +2 oxidation state is shown because of the removal of NS electrons. So, therefore, the correct answer will be option 3. That's all for the question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.